Alright, for this tutorial, we're going to go over how to solve linear equations. So let's take a look at our first couple examples. So here, for example 1, we have 2x plus 7 equals negative 3x minus 8. Now if you notice, we have variables on both sides of the equations. Now ultimately, we want to solve this linear equation, so we want to find a value for x. Now in order to do this, we need to do kind of like what we did in previous sections. We want to isolate the variable. Now right now, it's on the left side of the equation and the right side. So in order to isolate it, we need to get the variable onto just one side. Now it doesn't matter which side we put it on, we just need to get it on one side. So for example, let's start with our equation. And since it doesn't matter which side the variable goes on, let's move the negative 3x over here to the left side. So since it's a negative 3x, we want to add the 3x, which causes it to cancel out on this side. But we need to do the same thing to the other side. So plus 3x over on this side as well. So now we have 2x plus a 3x. This is like our combining like terms. So 2x plus 3x is going to give us a 5x. And then we still have the plus 7. And then we're just left with the negative 8 over here. So now from here to isolate the variable, the next step would be to get rid of this positive 7 here. So to do that, we'll subtract it from this side. So now it's gone. And we need to subtract it from the other side as well. So we're just left with the 5x over here on the left side. And then a negative 8 minus 7 will give us a negative 15. So now we have 5x equals negative 15. And in order to isolate the x, we need to get rid of this 5. Now since the 5 is being multiplied to the x, we'll just divide it to get rid of it. So 5 divided by 5 just cancels out to be 1, so we're left with 1x. And then we need to divide by 5 on the other side as well. So x is going to equal negative 15 over 5. Well, 15 over 5 is 3, but a negative divided by a positive is a negative. So for this example, when we solve the equation, we find out that x equals negative 3. Now let's try another example that's somewhat similar. So here we have another equation with a variable on both sides, but before we're able to isolate the variable on either side, we need to simplify both sides. So the first thing we could do is, if you notice, we have a constant number being multiplied to a quantity in parentheses. Same thing here on the other side. So what we can do to simplify is we could use the distributive property. So when we do that, for example, starting here on the left side, we have a negative 3 times this entire thing, x minus 1. So we could distribute the negative 3 to x and distribute the negative 3 to this negative 1 here. So let's do that. We have negative 3 times x, and that'll give us a negative 3x, and then a negative 3 times a negative 1. Negative times negative is positive, and then the 3 times 1 is 3. So now let's distribute it on this other side now. We have a 4 times a 2x, that'll give us an 8x, and then 4 times a negative 2. So a positive times a negative gives us a negative, and then the 4 times 2 is 8. So now we're at a point like how we started with example 1. we have an equation with a variable on both sides. So now we just need to isolate the x onto either side. So let's move it over to the right this time. So let's get this negative 3x and add it to cancel it out on this side. And then we need to add it to the other side. So we're just left with a 3 here on the left. And now on the right we need to combine like terms. So 8x plus a 3x will give us 11x. And then minus 8. Now to isolate x over here, we need to get rid of this negative 8. So since it's a negative 8, we'll add 8 to cancel it out on this side, which means we also need to add 8 over on the other side. So here on the left, we have a 3 plus 8, or 11, equals, and then we just have 11x over here. So to isolate the x, now we just need to get rid of the 11 by dividing. So we'll divide 11 to both sides. That leaves us with x equals 11 over 11, or in other words, 1. So when we solve this equation, x would equal 1. Now let's look at a slightly different application for this. Sometimes when we have equations, we can't necessarily find an exact value, but we can still isolate a variable. So for example, here with number 3, we have the typical volume equation for a rectangular prism. Volume equals length times width times height. Now right now, this equation is solving for volume. So the volume, or the variable v, is being isolated. Now instead of the v being isolated, they want us to solve for h. So let's isolate the h variable. So to do that, it's similar with what we've been doing before. So we want to isolate our h. So in order to do that, we need to get rid of the length and width, or the L and W. So since the L and W are being multiplied to h, we'll just divide them. So now the L will cancel on this side and the W will cancel on this side. And we do the same thing to the other side. So divide by L and divide by W. So that leaves us with h equals v over LW. So when we isolate h, we know that h will equal the volume divided by the length times width. Now this doesn't just work for equations and formulas that we already know. This works for pretty much any type of equation. So for example, here with number 4, we just have a random equation, x equals 3y minus 4 all over z plus 1. Now they want us to solve for y, so let's isolate our y variable. So we have x equals 3y minus 4 over z plus 1. So in order to isolate the y, we want to get rid of everything else. So the first thing to get rid of would be the z plus 1 down here. And since it's being divided, the only way to cancel it out is to multiply it. So we'll multiply by a z plus 1. So z plus 1 divided by z plus 1 cancels to just be 1. Now since we multiplied z plus 1 on this side, we need to do it to the other side. So we'll multiply by z plus 1 over here. So that leaves us with an x times z plus 1 equals 3y minus 4. The next thing to get rid of would be to get rid of this negative 4 here. So we'd add 4 to both sides. Now we just need to simplify. So x times z plus 1 plus 4. Nothing can combine there at the moment. So, and over here we're left with just the 3y. Now, just one last step to isolate our y, that'd be to get rid of this 3. So since it's being multiplied, we're going to divide it. So when we divide the 3, it cancels on this side. Then we just need to divide it on the other side. So that leaves us with y equals x times z plus 1 plus 4 all over 3. So this is what it would look like if we solved for y.